Okay, there we go. So on 16.3b, would you write equation here? Because like I said earlier, we're going to try and take features of an ellipse and then write the equation that it comes from. Sai said this one earlier, so I'm just going to write it, make sure everybody's got this. So it's going to be x minus h quantity squared over a squared plus y minus k quantity squared over b squared. And that equals 1 if we write it in the graph-friendly form. Again, you can think a squared minus b squared, but a's always got to be the biggest one. So if it would be better off if you thought big one squared minus small one squared, or little one squared equals c squared. And then how do you decide if the major axis runs horizontally in the x direction or vertically in the y direction? Somebody want to tell us? Mason?
Find what is longer.
Yeah, whichever one's bigger, okay? So whichever is bigger. Okay? And that's why we only need to memorize one format instead of a couple different formats that you might see in other textbooks. So we're going to look at example 1. It says write the equation in standard form, so that nice graph-friendly form for the ellipse that satisfies the given conditions. There's an axis set here for you. You do not have to graph the entire thing. It's just there if you need it. So we're going to put foci at 1, -4. So we'll be 1, -4. So right here, there's one focus. We'll put an F by that. And then 5, -4. So 5, -4 would be right here. There's another focus. And then vertices at 0, -4. So there's a vertex. And then 6, -4. So right there. So pretty clear to tell that we've got a horizontal major axis. The center, if you needed to, you could use the midpoint formula. But if you've got a focus over here and a focus over there, then the center is going to be right there. So we can identify that one. So that's going to be at 3, -4. There's the center. So if the center is at 3, -4, then we've got this. X minus 3 quantity squared. And then y plus 4 quantity squared equals 1. And then all we have to know is what goes underneath. So, well, in the x direction, this is how far we went. We went this far from here to here. So this is from 3 to 6. So that means in the x direction, we're going to go 3 units. So what number goes underneath the x? 9, because we square it. Okay, so in the direction we go 3, we're going to square that, and we're going to put a 9 right here. Then I've got to figure out this missing one right here, the b squared, if you want to think of that. So here's what I've got. I know that a is equal to 3. And from this little diagram, I can tell, hey, if I look at that, from the center to the focus, that's going to be 2. So that means c is equal to 2. So a is equal to 3, c is equal to 2. So we're going to do the big one squared plus the little one squared equals 2 squared. So this is going to be 9 plus b squared equals 4. Move that over to the other side, and I get b squared equals... Oops, I need a minus here, don't I? Yep. Yeah, thank you very much. A minus here. So that's a minus. That's a -5. So b squared equals 5, right? Do I need to take the time to figure out that b is the square root of 5?
No.
Colson's shaking his head. Colson, why not?
Because we just need b squared and we already solved b squared.
Yeah, we already solved it. And if we needed to graph it, then we'd want to find that because we're going to go the square root of 5 in each direction here. Okay, but we don't need that. All we need is what b squared is. So we're going to put a 5 right here. And there we go. So if you'll remember, I said normally what we're going to end up doing is we're trading some nice coordinates for vertices for ugly coordinates for foci, or vice versa. Nice coordinates for foci and ugly coordinates for vertices, which is what would happen here. Okay? Or, yeah, one of the 4 vertices, or 2 of the 4 vertices. Everybody good there? Okay. I'm going to give you a second to look at number 2, or part B. D, huge advantage on this one. What is it? Yeah, I'll even take this. They told you the center, so that means this is H and this is K. So we can immediately start writing this stuff down. We're going to write x minus 2 quantity squared, y plus 2 quantity squared, and we'll have that equal 1. So we're on the right track to start with. And then we'll use the diagram to help us figure out what's going on here. So if the center is at 2, -2, there's the center. And we've got a focus at 2, -6. That's way down here. And then we've got a vertex at 2, 3. That's up here. Bunch of symmetry, right? If this is the vertex, this has got to be the major axis. That means there's got to be another focus over here. So if you'll notice, this distance right here is 4. So we could go 1, 2, 3, 4. We're going to have a focus right there. So that means this is C. And that means we can figure out this right here. Let's see, that would be an A of 5. And I'm going to ask Jack. I need A squared. That's going to be 25. What does it go underneath? Does it go underneath the X squared or the Y squared?
The Y squared.
Goes underneath the Y squared. How come?
Because it's going.
Yeah, because we're going in the Y direction. So this is going to be a 25 right here, and then we're going to use the same type of formula. So this is going to be the big one, which is going to be 5 squared, minus the little one, whatever that is equal to C squared, so that's going to be 4 squared. So I'm going to end up with something similar here. Let's see. This is going to be a B squared, and when I subtract 25 here, that's going to give me a -9. I'm going to take that off. Whoops. So I get a 3, right? That would be kind of cool. But I just put a 9 right here, correct? Because I don't need to graph it. I'm just going to put a 9 there. Now, does anybody have any questions? We good? Yes? Okay, slide down, take a look at the next one. This one gives us vertices. So 5, 2, -5, 2, and 3, 2. Those are vertices. So we know we're running horizontally with a major axis. And then it says the minor axis is 6 units in length. So if I'm back here at -5 and right here at 3, the center of that would be 1. So the center is going to be right here. So -1, 2. And if the minor axis is 6 units long, that's telling us we're going to go 3 units in this direction and 3 units in this direction. So we've got a couple things here. This distance right here is 4, and that's got to be A. And this distance right here is 3, and that's got to be B.
Yes.
So x minus 1, quantity squared. Y minus 2, quantity squared. That's going to equal 1, and then no formulas or anything like that. We're going to put a 16 underneath the x, because in the x direction we went 4 units from the center, so we're going to square that. In the y direction we go 3 units in each direction, so whoops. Remind me later. Okay. Okay. Any questions there?
No.
Easy enough?
Yes.
Okay, flip the page over.
Okay.
Okay, one more to do. It says find the center, vertices, and foci of the ellipse and then graph the equation. So we need to do all of this. Okay? And in order to put it in that format, again, there's perfect squares in each one of these conic sections. So I'm going to arrange these together, and we're going to keep in mind some stuff that we did about a month ago. When we're completing squares, just like we did with parabolas and with circles, we've got to be compensating on both sides. So I'm going to write the x's together, kind of just out of habit. I'm going to save room to complete the square, and I'm going to put the y's over here. Again, moving that constant to the other side, so this is going to be a 32. Now I'm going to double check and make sure I haven't made any silly mistakes, because it's a lot of work to complete the square. And if I make silly mistakes, it's just going to get ugly. So let's see, I've got the 4x squared, I've got the 8x, I've got the positive 3y squared, I've got the minus 12y, and I moved the 32 to the other side so it became positive. Everybody good?
I think that is correct.
Okay, there's something I have to do with both of these expressions with x and y before I can complete the square. Can anybody tell us what it is? Keely?
You have to take half of the middle coefficients.
That's part of the completing the square process, but I can't start that until I do something else. You're right about that. Lizzie? We do. You cannot complete the square unless the number in front is a 1. So we're going to rewrite this as a 4x squared plus 8x. And if you, 2x, thanks. If you take out a number, especially if you take out a negative number or something like that, you've got to be really careful. So I'm going to save room to complete the square. Then I'm going to take out the 3. I'm left with y squared minus 4y. Close that set of parentheses. And all I've done here is just rearrange. I haven't changed anything yet.
Okay.
Now I'm going to change something. So, Keely, what do I do now right here?
Take half the middle.
Take half that. So that's going to be a positive 1. I'm going to circle it. I like putting the plus there because it's a good reminder. I'm going to take half of this. This is a negative 2. Put it right here. And I square this, so I'm going to add 1 here, and I'm going to add 4 right here. I square each one of those. I put them in there. I've made a perfect square. Inside each one of those sets of parentheses is a perfect square. But now I need to compensate for that because I have changed this side. Does anybody know what I need to do? I got to be careful here. Angela?
Add it to the other side.
We do have to add it to the other side, but I'm not going to add 1.
Wait,
Dane?
I have like 4.
You are, because what I really did by adding a 1 on the inside is, remember, we multiply the 2 of these together. What I really did is I added 4 here. So I'm going to compensate by adding 4 on the other side. So you have to multiply by whatever you did on the inside by the factor on the outside. And what I really did is I added 12 on this one. So I'm going to put a plus 12. Good? Okay, now I'm going to switch back to red and see what we've got. We've got 4x plus 1 quantity squared. I've got a 3 and y minus 2 quantity squared. And then on the other side, if I add all these together, I think I get 48. Is that right?
Yeah.
One last step to get it in that graph-friendly format.
Yes.
And here's what I've got. X plus 1 quantity squared over 12. Kind of ugly, but we can deal with that. Plus y minus 2 quantity squared over 16. We kind of like that one. And then we've got a 1. Good? Okay. So the center is going to be at negative 1 comma 2. So there's our center. In the x direction, we're going to go radical 12. Okay? So I'll write it properly. This is going to be b squared equals 12. So that means b equals 2 radical 3. We okay with that? So that's a little bit more than 3. So in the x direction, we're going to go a little bit more than 3, and I'm going to put a dot there and a dot there. Then I'm going to go in the y direction, square root of 16, so we're going to go 4. So I go up to here, and I go down to here. And just for the heck of it, so I can make this look kind of nice, I'm going to draw that little rectangle around there. And it goes like this.
No way. Still a potato.
What'd you say?
Still looks like a potato.
It does still look like a potato, but it's a more,
It's probably better than your
Yeah.
potato.
Okay.
That one.
it does. Okay, so I've got vertices right here, so this would be negative 1 comma negative 2. I've got a vertex up here, and this would be at negative 1 comma, let's see, I added 4, so that would be 6. And then I need some foci, and in order to find the foci, I'm going to do the big one minus the little one. So that's going to be 16 minus 12 equals c squared. So that's 4 equals c squared, so that means c equals 2, which is nice because we have that trade-off there. So I'm going to go 2 up here and 2 down here. So this focus and this focus, let's see, negative 1 comma 4 and negative 1 comma 0.
Pretty rad.
Did I make any mistakes?
No.
Okay. Luke.
Your mistake was wasting time by labeling it, because according to the instructions, it doesn't say label.
Oh, you don't think so? I would label them. Okay? because we're always going to label when we graph. Okay, any questions? All right, perfect.